Video 6. Perimeter of rectangle is 50 units, and we start immediately by adding a W on the right since we have one on the left, and then we make the length L for now, and then we write perimeter is 50 implies that 50 is equal to 2 times the length plus 2 times the width. We divide by 2 on the left and on the right, and we then get 25 is L plus W, or L is equal to 25 minus W. If you consider the right angle triangle that you see here, we can use the theorem of Pythagoras, and we can say that R squared is equal to W squared plus L squared. And instead of L, we're going to write 25 minus W squared. That gives us W squared plus 625 minus 50W plus W squared is R squared. We simplify by adding the two like terms. 2W squared minus 50W plus 625 is equal to R squared. Let's just go back to the question again. It says, find W if R is a minimum. Find W if R is a minimum. Now, let's quickly write this expression in terms of R. R will be equal to the square root of 2W squared minus 50W plus 625. And you see, if you go back to the question, for R to be a minimum, you need to look at the right-hand side here. The minimum value of R is the square root of the minimum value of the expression that you see in brackets. The minimum value of R is equal to the square root of the minimum value of that expression, simply because the expression is a variable expression. Now, if you write that expression down again, that is 2W squared minus 50W plus 625, the expression that you see there, that is a quadratic expression, and you can write that as a parabola. Y is equal to, if you sketch this, it's simply going to be a parabola that has that type of shape, and the very important characteristic here is that it has a minimum turning point, and that minimum turning point we obtain where W, or X rather in our case, usually X or W in this case, is equal to minus B over 2A. B is minus 50, so it's minus 50 divided by 2A. A is 2, so it's positive 50 over 4, and positive 50 over 4 is 12.5. And when W is equal to 12.5, R will be a minimum, and therefore the answer is C. Alright, let's move on to the next question. Some of these questions are quite complicated. You can look at the video a couple of times just to make sure that you master the skills and cement the understanding. Question 123, given semicircle with center K and radius T, find the maximum area of triangle KNV. Now here sits the triangle that we need to maximize the area of, and the very important part of this sketch is, of course, the center of the circle K. Now, consider the two very important line segments there. That's KN and KV. They are, of course, the radii of the circle. The radius is T. And then we can write down the area of triangle KNV, and the area of triangle KNV is, according to the area rule, a half times A times B times the sine of C. In our case, A is T, that's one of the sides, you can see it there in the sketch, and the other side is also T, and sine of the included angle, that is, I'm going to call it sine of k. So this simplifies to a half t squared times the sine of k. Alright, now very important to take note that this triangle could just as well have been there. Remember that the only fixed part of this triangle is the center, and what I'm saying is that the two radii, t that you see there and t that you see there, that's a constant, but the variable is the angle k. Alright, so if you consider the two triangles that I've sketched now, the one is blue and the other one is pink. And if you consider these two triangles are such that the variable is angle k. Let's look at the blue triangle again. There sits angle k. Alright, angle k is in the blue triangle smaller, and in the pink triangle it is bigger. So angle k is the variable. There is the variable in the area formula, k, and therefore sine of k. Now if you consider sine of k, which is a variable, and you draw the sine graph, there's the sine graph. We call this now the k-axis, and the graph that we've sketched is y is equal to sine of k. For us to find the maximum area of the triangle, we're therefore going to find the maximum of sine of k. And the maximum of sine of k is 1. It's 1 when k is 90 degrees. And so for us to find the maximum of sine of k, we simply replace sine of k by 1, because sine of k is 1, is the maximum. And if sine of k is 1, the area is therefore equal to a half t squared. And a half t squared is the same as t squared divided by 2. And there sits your answer. Well done.